All right, today we are going to cover our last section of new notes. We are going to talk about spheres. So we are going to talk about surface area and volume today, but all of it dealing with spheres. Our warm-ups are similar to what we were just doing, going over our homework. So we are finding the total surface area of each figure. The first figure is what type of solid? A cone. So to find the surface area of it, we just talked about this formula. What is it?
B?
No.
No, it's the
Pi r. Oh, pi r.
Pi r squared plus...
Pi r.
Good. Pi r squared plus pi rl gives us our surface area for a cone. They made it easy on us because they gave us both the radius and the slant height right away. What's my radius? 5. And my slant height? What is it? 13. Remember, the slant height is that slanted side of the cone. They gave it to us right away. We don't have to find it. 5 squared. So we have 25 pi plus 13 times 5. 65 pi. Add them together. 90 pi. My units. Meters squared. If you wanted to multiply it out, you can, but I'm totally fine with you just leaving it as 90 pi meters squared. That being said, if you forget to write your pi and you just write 90, then you're getting it wrong. You gotta have the pi. Questions about that? Okay, on the next one, what type of figure do we have?
Regular pyramid.
rectangular.
Okay, we've got a rectangular pyramid. Not a prism because it only has one base. To find my surface area, I need capital B plus 1/2 PL. What is capital B on this one? Brandon?
Is there no such thing as a square and angular pyramid?
Is not an appropriate name.
Oh, what? A square and angular.
So to find capital B, we take 25 squared and we get 625. Plus 1/2 times, how am I going to calculate P? Add up how many sides? 4 of them. So we get 100 times, what is cursive L? 32. The slant height is 32 feet. Okay, so now you can decide how you want to calculate this side of it. We took 25 plus 25 plus 25 plus 25 to get the perimeter.
So we couldn't take half of 625?
It'd be 2,225.
Total.
Yeah.
Okay, we do not take the half from the 625. You could take half from the 100 and then multiply it to 32. And the very last thing we do is add it to the 625 at the end. We still need units though. What should my units be? Feet squared. We don't need a pi because this is not a cone. It's not a cone or a cylinder. We only use pies when we have a circle involved. All right, we've got our vocab. First up, a sphere is technically defined as the set of all points that are the same distance from a point called the center of the sphere. I believe most of you are pretty familiar with what a sphere looks like in general. Okay, most things like a basketball, a baseball, a beach ball, these are all physical representations of what a sphere is. So somewhere in the very middle of it, so not a point that you could touch, in the middle of it you would find the center of the sphere, and all the points on the outside that you would touch if you were holding it would be equidistant from that center. A hemisphere is a geometric plane passing through the center of a sphere. It divides a sphere into two hemispheres. So a hemisphere is basically half of a sphere, if you want to put that down.
Half the world. Use me, 'cause I was making use half the.
As promised, because we have circles involved when we're talking about spheres, both our surface area and volume formulas involve pi. So to find surface area or volume for a sphere, the only thing we need is the radius. We don't need to worry about heights, slant heights, anything else. Surface area is 4 pi r squared. Volume is 4/3 pi r cubed. If you want to rewrite volume as 4 pi r cubed, all of it divided by 3, that's the same thing. So sometimes it might be easier to multiply by 4 and then divide by 3 at the end, instead of thinking about the 4/3 as a fraction. It comes out the same either way, but I find for most students they prefer it split up as multiplying by 4 then dividing by 3. All right, we are finding the surface area of these spheres. What was our formula for surface area? 4 pi r squared. Remember, area, our units are always squared, so we square the radius. For volume, our units always get cubed. That's when we cube the radius. So that might help you keep it straight. One of them gets squared, the other gets cubed. What is my radius on this sphere? No. 7.5. They gave us a diameter, so we have to cut it in half to get the radius. Then the only thing we have to do is plug in our radius to our formula. So we have 4 pi times 7.5 squared. Jaden?
651.4. I mean,
Okay, Jaden, one more time. What's 7.5 squared?
56.25.
Okay.
I have a question.
What do you think we need to do that 56.25? Multiply it by 4, and what do we get? No, it should come out to a whole number.
225.
225. If you're taking something that's 1/4, 0.25 is a fourth, and multiplying it by 4, it should come out to a whole number.
Do we have the positive?
We still have the pi. What are our units? Meters squared. We could leave it there, or we can multiply out our pi.
76.8.
They said round to the nearest whole number, so we would round it to... Whoa, what?
707.
Okay. When everybody mumbles at the same time, my brain doesn't comprehend it very well. All right. Are we good with our surface area on that first sphere?
Yes.
On the next one, what is our radius?
3
3. That's going to make our life a little bit easier when we plug into our formula for surface area. We have 4 times pi times 3 squared. What is 3 squared? Brandon?
I got a question for the last one.
Okay, question on the last one?
Are all units gonna come out as equivalent?
Not necessarily. Well, when we round, if it says round to the nearest whole number, then we should always round to the nearest whole number when that's what the directions say. But as far as the number in front of the pi, it does not always necessarily have to be a whole number. Okay, what was 3 squared? 9 times 4? 36. So we could just leave this as 36 pi inches squared. Or we could multiply 36 times pi and round to a whole number. Anybody do that?
It'd be 113, I believe, right?
113 inches squared. So either of those would be acceptable. When we find volume, again, we've got the 4 pi. This time the radius gets cubed, and we're going to divide the whole thing by 3. Okay, so what's our radius on number 3? 12 inches. So we have 4 times pi times 12 cubed, all of it divided by 3. So I would recommend doing everything but the pi at first, meaning that we take 12 and cube it. Anybody get 12 cubed? So you could take 12 times 12 times 12 if you don't know where the cube button is on your calculator. 1728. Is that before or after you multiplied it by 4? Before. So when we multiply it by 4, 6,912. And what do you think we should do with that 6,912?
Right.
Divide it by 3. 2,304. What do we still have with it? The pi. Our units would be inches cubed because this is volume. All right, on our next example, what's our radius?
4.5.
How'd you get that?
Subtract 9 minus, and then take
Half
half of 9.
of 9 is 4.5. That would be an acceptable explanation. So when we go to plug that into our volume formula, we have 4 pi. The 4.5 gets cubed. The whole thing gets divided by 3. Now again, if you don't know where your cubed button is, you can take 4.5 times 4.5 times 4.5. If you want to go ahead and take that times 4 while you're here, you can do that. This one does still come out to have a decimal. Well, I wouldn't round anything yet. Go ahead and multiply that 91 number by 4. Okay, still multiplied by pi and still divided by 3. Now this is one, because the pi, the number in front of the pi doesn't come out nicely. When we divide by that 3, we still have a decimal. So this one is one where you might want to go ahead and multiply it out anyway. I'll start putting this up at the top, so I'm running out of room. So right here, if we divide the 364.5 by 3, what do we get? Connor?
I got 121.5.
Good, and that's still getting multiplied by the pi. Technically, we don't really want a decimal with the pi. If you were to do that, because you're in that habit, as long as you put your units on it, it's fine. But this is one where I probably would prefer that we actually multiply out the pi.
You would get 381, which is around the whole thing, so 382.
Good, so rounded, we would have an approximate volume of 382 feet cubed. So I would accept either one of these, but on ones where you've got a decimal number in front of the pi, I'd probably rather you just multiply it out. If you forget to do that because you're in that habit of leaving pi in there, it's fine. As long as this number in front of the pi is not rounded. That's when it's a big no-no. A hemisphere is how much of a sphere? Half of it. So they ask us to find the volume of it. So we will find the volume as if it were a whole sphere and then divide by 2.
Easy.
Now they told us the diameter is 22 centimeters. So what am I using as my radius? 11. They asked for volume. So which formula do I want?
4 pi r cubed
Over 3. Good. So we've got 4 pi 11 is getting cubed. The whole thing divided by 3. When we take 11 cubed, what do we get?
1,331.
Okay. So we can take that times 4.
5,324.
And then we should take that number and see if it divides nicely by 3. It does not. So in my calculator, since I've already taken this divided by 3, while that big number, the 1774.6 repeating, while that's on my screen, I'm going to go ahead and type in times pi. And what do I get approximately to the nearest whole number?
1,670. Oh.
Or if you did not take the 5,324 divided by 3 and then multiply it by pi, you can take 5,324 times pi and then divide by 3. It'll come out the same. Jaden?
16,726.
Is that before or after you divided by 3? Okay, go ahead and divide by 3. We'll just do it all at the same time. Now what'd you get?
5,575.
Good. But is that our final answer? No.
Divided by 2.
We still have to take that and divide it by 2. So what do we get? 88. My units? Centimeters cubed. Good. Yes.
So where did 5,575 come from?
We took the 5,324, multiplied it by pi, and then divided it by 3. So we just did all of that on our calculator before we wrote it down.
How do you get the 2,788 from
So this volume is the volume of a whole sphere, but we only have a hemisphere or half of a sphere. So we had to take the 575 divided by 2 to get the 2,788. We ready for our last example? Okay. On this last one, we are finding the volume of a hemisphere again, so same steps as last time. On this one, what is my radius?
16.
What?
Oh, wait, my bad.
18 centimeters. Half of the diameter. So for my volume, I've got 4 pi. My radius of 18 gets cubed. The whole thing divided by 3. I would recommend taking the 18 cubed and going ahead and multiplying by 4 in your calculator. But if you want to do it as 2 separate steps, you can.
You get 5,000. If you just do 18 cubed, you would get 5,832.
Okay?
And times it, you would get 23,328.
Okay.
Divided that by 3, and I got 7,776.
And that still has the pi. Now this number's coming out nicely. Is this our final answer?
No.
No. So what could we do to this to get our answer? Divide by 2, which it'll still come out nice. And what do we get?
3,888.
Oop, 888. Still multiplied by pi, my units. Centimeters cubed. Now, if you wanted to multiply out the pi and round, that's fine. But since this number came out nicely, we don't really have to do that.